Hello and welcome to today's lesson. I'm your hard-working but indefatigable teacher, Mr. Burton. You will need to watch this video and take notes as you go. You may need to watch certain parts of the video a few times to ensure complete understanding. This is your homework and I will check your notes tomorrow before we get started. I hope you learned something.
Okay, on to today's topic, and this is about the demand function. High-level topic. With a little bit of mathematics involved. Okay, the demand function takes the form of the equation QD equals A minus BP. And an example demand function there is given there, QD equals 100 minus 10p. So QD, we just talk about the quantity demanded. So the equation determines the quantity demanded, and the equation states how the price, which is P, of a good or a service, determines that quantity demanded. An equation that lets you know how a variable like demand is determined is called the linear function. And we know that our demand curve is a straight line, and the linear function produces a straight line when it's grey. So two different demand curves over there, each with their different functions. The green one being steeper, the red one being less steep. Quantity demanded. The quantity demanded when price equals 0, because B times 0 equals 0. And this is going to tell us how steep the demand curve will be. It's the coefficient that determines the slope of the demand curve from steep to flat, steep being the green one that's shown below, a relatively more flat one, the red demand function, demand equation. And this essentially measures how responsive the change in quantity demanded is to changes in the price. Because sometimes a small price change can produce a large change in quantity demanded, maybe where there are lots of different alternatives for the consumer to choose between. So a large number of substitute goods the consumer can switch to. If there's a price increase with one, consumers are going to switch to those other substitute goods, and it's going to be a big drop-off in demand. And sometimes a large price change is only going to result in a small change in quantity demanded, maybe because that good is a necessity. An example there would be petrol. People need petrol to get around. Now, B is always negative because we have an inverse relationship. Increased price, decreased quantity demanded. Decreased price, increased quantity demanded. So it's inverse, and B is always negative as a result. And that just stems from the law of demand. Calculating quantity demanded from a demand function. Okay, using the demand function to calculate the quantity demanded when the price is $5. That's when P in the equation is $5. So our demand function QD equals 100 minus 10p. 10p means 10 multiplied by the price. So QD equals 100 minus 10 times p. 10 times p in brackets because you need to calculate this part first. So QD equals 100 minus 10 times 5 in brackets here, 5 being the price, $5. And we simplify that by multiplying 10 by 5. So step by step, very, very easy. QD equals 100 minus 50. And we simplify that again by subtracting 50 from 100. 100 minus 50. So the quantity demanded when the price is $5, the quantity demanded is 50. Constructing a demand schedule. So what we've got here, price on the left, quantity demand on the right, and our workings out in the middle here. So when the price is 0, with the demand function, QD equals 100 minus 10p, which simply changes 0 for the p and multiply that out and then subtract. 1, we're substituting the P for $1, and when we do that, the quantity demanded is 90. Price of $2, P becomes 2, multiply it out, subtract the 20 off, quantity demanded is 80, and so on, and so on, and so on. And when the price is $10, we can see that the quantity demanded drops all the way down to 0. At a price of $10, we have 0 as our quantity demanded. And as it turns out, that 0 quantity demanded will be our x-intercept when we start plotting this information. Okay, if the demand function for a particular good or service was twice as steep, so for example, 20 for B instead of 10 as in the table above, the quantity demanded would be twice as responsive to changes in price. The quantity demanded would fall twice as fast. Let's have a look at that now. So we've changed the demand equation. Now it's QD equals 100 minus 20p. So instead of 10, we have now got 20. So price information is the same, and we're just changing the other part of the equation. So we can see there that quantity demand is falling away twice as quickly. And at a price of $5, it reaches a quantity demanded of 0. And in fact, here we have those two different demand functions graphed for us already. So we can see that the demand equation QD equals 100 minus 10p. That was what the first demand schedule we created. And when that became twice as steep because it changed to minus 20p instead of minus 10p, the quantity demanded started to fall off twice as quickly, twice as steep. Right, so we're going to take a demand schedule and we're going to plot that. And we don't need a whole demand schedule to be able to draw the demand curve. All we need are 2 points. So that's really important. We can save ourselves a whole lot of work here. We know that the demand curve is a straight line. If we can find where that straight line hits the x-axis, we can plot a point. And if we can determine where that straight line hits the y-axis, we can plot a point. Remember, x-axis being the quantity demanded, y-axis being the price. So, to find these 2 points, all we need to know is the quantity demanded when the price equals 0. That'll give us the x-axis intercept, and the price when quantity demanded equals 0. And this is the y-axis intercept. Step by step. Our original demand function, QD equals 100 minus 10p. So we're going to set that price to 0. So quantity demanded equals 100 minus 10 times 0. 10 times 0 is, of course, 0. And 100 minus 0 is 100. So this becomes the x-intercept, where our demand curve crosses the quantity demanded axis. Now let's go find our other point. We're going to set quantity demanded to 0. So that means quantity demanded is 0. 0 equals 100 minus 10p. And we just have to do a little bit more work this time. We're going to rearrange that equation by bringing the negative 10p across the other side of the equals line. That becomes 10p equals 100. Straight from your year 11 maths. And we're going to solve that now. So P equals 100 divided by 10. Price equals 10. And that becomes the y-intercept. So, pretty straightforward maths. Step by step. You just need to practice it. It's easy, easy, easy. Practice, practice, practice. And then we can go ahead and plot our x-axis, which is 100 and 0, and our y-axis, 0 and 10. So there we go, 0 and 100, 100 and 0 for the quantity demanded. So when price equals 0, the quantity demanded equals 100. Whereas when the quantity demanded equals 0, that's the price of $10. Our 2 points, we know it's a linear function, straight line. Just draw a line between these 2 points. And there we have it. You have plotted your demand curve. Shifting a demand curve. Here is our first function, QD equals 100 minus 10p. And we've been through and made these calculations before. This is our demand schedule. Take that all the way down to 10. So price of $10, quantity demanded drops to 0. Now, we're going to shift that. So instead of quantity demanded equals 100 minus 10p, we've got a demand decrease here. And demand is decreased. The curve to shift left to QD equals 80 minus 10p. We can go through and do our new calculations on the new demand function. So step by step, pretty easy. And if we go through and plot that information, this is exactly what we have. The original demand equation, quantity demanded equals 100 minus 10p. There's been a decrease in demand. That 100 has decreased to 80, and our demand equation has now become quantity demanded equals 80 minus 10p. Shifted to the left. And I think you can see from that, if demand increased, then that original demand equation, QD equals 100 minus 10p, the 100 would have got bigger, would have shifted to 110, 120, 130, etc., etc.